This is going to be a video lesson for section 8.6, the use of cube roots and fractional exponents. We're actually not going to do the fractional exponents part, we're only going to concentrate on the cube roots. So that's the only part of 8.6 that we will cover, and that's the only part that you'll be responsible for on the assessments. So cube roots are very similar to square roots. So before I actually do cube roots, let's go back and take a look at what a square root is. So square root is the lowest type of a radical. You could have roots to the power of 1, but those really don't do anything, so we don't write them. So square roots are the smallest type or the lowest level of roots that actually have an effect mathematically. So that's a symbol for a square root. Now we don't write the little 2 here. If you remember when I went over the square root, I told you that that 2 is over there, and it implies that that's a root to the second power. But because that's the lowest level of root that's used, we don't write that 2, but it's there, and the 2 gives the square root its name, a squared root. And if you have, for example, a perfect square like a 4 underneath the square root, I told you that perfect squares, because they're essentially an integer to a power of 2, and the square root, because it's a square root, the power of 2 of the root and the power of 2 in the exponent, they cancel each other out. So a squared root and a power of 2 are pretty much opposites, so they will cancel each other out. So, another example, if you had the square root, and I'm not going to write the 2 now, for example, let's take another perfect square, 25. 25 is 5 squared, 5 to the second power, so you can cancel out your power of 2 in the square root and you get a 5 out of it. So cube roots are very, very similar. So if that was a square root, this is the symbol for a cubed root. Same radical symbol, except now the number is a 2 instead of a 3, and we always have to write it. In the square root, you didn't have to write the 2. In the cube root, you have to write the 3. And any power of root afterwards, they all have numbers. We're not going to look at anything higher than 3, but they exist. You can have roots to the power of 4, roots to the power of 5, and so on. And just like with a square root, where it's essentially the opposite of a power of 2, a cube root is the opposite of a power of 3. So if I gave you this problem right here, the cube root of x to the third power, just like in this example over here where you would cancel out the power of 2 and the square root, you can cancel out the power of 3 and the cube root. They are exact opposites. Now you can't mix them. You can't cancel out a cube root with a power of 2. For example, if you had this, a cubed root, and x to the second power, can't really do anything there. Power of 2 and the power of 3, they're not the same, so that case can't do anything there. But in this case, that equals out to just an x. Another example, if I take the simplest numerical perfect cube, so to speak, that's not a 1, it's going to be 2 times 2 times 2, which is an 8. So I can take the cube root of 8. It's a perfect cube because it's essentially 2 to the third power. 2 times 2 is 4 times 2 is 8. And just like with perfect squares and square roots, you can cancel out the power of 3 and the cubed root. And so all you end up with in the end is just a 2. Let's do another example. So perfect cubes, they grow much quicker than perfect squares. I mean, perfect squares, you started out with 4, then you went to 9, then you went to 16, then you went to 25, 36, 49. So the growth was pretty small. With perfect cubes, it grows much quicker. So you get 8, then you get to 27, that's 3 times 3 times 3. Then you get to 64, which is 4 times 4 times 4. Then you get 225, that's 5 times 5 times 5, and it just grows out of control to the point where 10 squared is 100, 10 cubed is 1,000. So you can see how quickly they grow. So memorizing anything past the fifth power of 3 or 5 to the power of 3 becomes a little bit cumbersome. So let's do exactly that. The cubic root of 125. Well, 125 is a perfect cube, which means it's 5 to the third power. And again, you can cancel out the power of 3 and the cube root to get a 5 as your answer. And you are going to be responsible to at least know the perfect cubes up to 125. That's a bare minimum. Anything past that, I'll probably won't ask you on the quiz, but 125 is fair game. Now, something that you didn't encounter with perfect squares was this, or square roots in general. You did not have any negatives underneath the square root. The reason being, there is no two integers that are the same when multiplied that will give you a negative 4, because 4 is a perfect square. It's 2 times 2. So you can't have negative 2 times negative 2. That's going to be a positive 4. And if it's a negative 2 and a positive 2, then it's not the same integer anymore. It might look pretty close, but it's not the same integer anymore. So we couldn't have this with square roots. With cubed roots, though, it's actually very normal to have negatives underneath the cube root. Now, why is it okay for cube roots and not okay for square roots? Well, because you can have this, which is a negative 2 to the third power. Negative times negative is a positive, times negative is a negative. So in cube roots, you can have a negative underneath the root because it's an odd power, and with an odd power, the negative times a negative times a negative will yield a negative outcome. So in this case, the negative 8 can be represented as a negative 2 to the third power, and that cancels out just fine. And the answer in this case is just a negative 2. The problems from homework, you're going to be mixing. You're going to have some problems where you're just figuring out the cube root, but then you're going to have some problems where you're mixing cube roots and square roots. And that's about it. This is a fairly easy section. So thank you.